Greetings everyone. Why can somebody be extremely good at and strong at performing one particular movement or exercise and then perform poorly on another exercise that is very similar? Or let's say, why can a very good runner cannot be a very good cyclist? Why can months and months of training produce exactly the adaptation that you practiced, but not necessarily the one that you expected? This is called the set principle. This is the specific adaptation to imposed demands. So your body adapts according to the demands you repeatedly place upon it. But the adaptation is specific. And then if you train for heavy resistance, you become very good at and you develop qualities required to produce great level of force. But let's say if you train with sub-maximal levels repeatedly, then you become very good at resistance to fatigue. But let's say do explosive movements, then the central nervous system will map so that you become very good at producing force very quickly. And then if you do particular movement or particular exercise, then you become very skilled and very good at this and very efficient. This is why saying simply I exercise doesn't tell us much. The important question is what demand are you asking your body to solve over time repeatedly? Getting stronger isn't only about building larger muscles. It is also about the central nervous system that kind of coordinates and map out certain neurological pathways, the connection between the different muscles that are needed to perform that exercise. This is why improving bench presses doesn't necessarily mean that you'll be very good at and improve in other pressing exercises. Yes, there can be transfer. It depends the transfer, how similar the different exercises are. The adaptation can be influenced by the joint angle, the range of motion, the movement pattern, and the velocity. The same set principle matters for hypertrophy, but this needs to be interpreted carefully. What set is saying that there is no magical angle, there is no magical movement, there is no magical tempo. Instead, exercise execution changes the mechanical demand across the body. Change the range of motion, change the body position, change the resistance or the technique, and you see how the different muscles are contributing for the execution of that exercise. So the balance is changed. For hypertrophy, the goal is therefore not perfect isolation. How the muscle is being built is because of mechanical tension. We need to expose the muscle to a mechanical tension. This is the goal. How we are going to do this? Through exercises that over time you can repeat them, so they are repetitive exercises, and you need to impose progressive overload. If you can do this and if you can track it by applying mechanical tension on the muscle will grow. So this doesn't mean that the muscle is perfectly isolated, but specificity also creates a trade-off. The more specific your training becomes, the better prepared you may become for one particular task, but then you're potentially neglecting the others. For example, let's say the powerlifter needs highly specific practice of the competition lifts. A sprinter needs to train the muscle and the central nervous system for high-speed running. An endurance athlete needs prolonged aerobic work. And then if you train for general health, that requires something different again. So there is no universally perfect program because the goal of these different tasks are different. So there is no one ideal goal that everybody can train. So whenever you design your training, start with the adaptation you actually want and then work backwards. Do you need strength? Do you need power? Do you need muscular endurance? Do you need hypertrophy, movement skill? The training stimulus should reflect the outcome. Your body cannot read your program. It can respond to the demand that the program creates. Specific demand, specific adaptation. That is set principle. The system is locked. I'll see you next time. Let's evolve. Cheers.